All right, we are going to practice making a graphic organizer comparing the differences between wave speed and wave energy. You can have big or small waves carrying different amounts of energy, and that has to do with how much energy we get in our cell phones, our electronics, the electricity in our homes, as well as a lot of other applications in our natural world. So of wave speed is how fast or slow a wave is moving. Wave energy is how big or small it is. Okay, so even though they're different, we're studying them together because when we do calculations, we can figure out if fast waves are carrying big or small amounts of energy, slow waves carrying big or small amounts of energy, etc. The formulas are based on the way the waves are structured. You do not have to memorize the formula, you just need to know how to use it. The formula for wave speed is frequency times wavelength, where frequency is measured in hertz or hertz and is the number of waves that pass through a certain point in 1 second. And wavelength is either L or lambda and uses a distance metric system to measure it, and is how long the wave is from either trough to trough or crest to crest. So frequency and wavelength have nothing to do with wave energy. Wave energy is a function of the wave's amplitude. The formula for wave energy is amplitude squared. Amplitude is how big or small it is. And it's measured from the midline to either the crest or the trough, but not from the full amount. Okay, and that's also measured in meters. Okay, it might be kilometers, it might be nanometers, but either way, meters is we use the metric system for those. So if I just gave a wave, we can use its properties to figure out how much energy it's carrying and how fast it's going. And the better we can make both efficient, the more technology we get and the more energy we can get in our homes and all sorts of applications. So using this midline, I can say that the amplitude from this midline to either the crest or the trough, doesn't matter, is A equals, let's say 5 meters. Amplitude equals 5 meters. You never have to calculate the frequency, you're given that. Frequency equals, let's say 11 hertz. And wavelength, so L or lambda, let's say is 6 meters. So once I determine these measurements, then I can determine the wave speed, which is frequency times wavelength, or frequency 11 hertz times wavelength 6 meters, which is 66 meters per second. That means in 1 second, that wave traveled 66 meters. That's pretty fast. Definitely faster than the fastest car on the freeway. And that's going to be called, and this part right here is called the unit of measure, because otherwise if you just say 66, it doesn't make sense. 66 what? Loaves of bread, feet, marshmallows. Okay, you got to be specific. So it's 66 meters per second, which is a function of how fast something is going. Versus the energy, wave energy, is amplitude squared, which is wrong number. Okay, amplitude is 5. 5 squared, which is 5 times 5, or 25. And anytime we talk about energy, we use kilowatts as the unit of measure, because it's just like using our light bulbs or the energy in our cell phones or the energy coming into our homes from the electrical grid. Okay, so you can change the speed and it won't change the energy, and you can change the energy and it won't change the speed. You might change the frequency or the wavelength and it might affect the speed. And of course, when you increase the amplitude, the energy is going to increase because it's going to be an even bigger wave based on that function. But if you change the energy here, you're not necessarily changing the speed. However, we're still talking about one wave. And so we can figure out wave behavior just with these two formulas. Again, you do not need to memorize the formulas, but you do need to know how to use them and provide a complete answer. Thank you. Bye-bye.